So today we will see the IUPAC nomenclature. In that you will have these compounds. Bicyclic compounds are there, then biphenyls, then cumulines. So bicyclic compounds, these compounds have more than one ring system. The compounds, okay, normally these compounds, bicyclic means bi means two. So these bicyclic compounds contains two ring systems, and these are the saturated and the unsaturated compounds, and 11 carbon atoms, up to 11 carbon atoms are present in this. So bicyclic compounds we are going to see. So the compounds, normally the compounds having more than one ring system are called the polycyclic compounds. And the bicyclic compounds are those compounds in which only two ring systems are present. The second one, there is a biphenyls. There is a biphenyls, and third one is a cumulines. So cumulines, it contains up to 3 double bonds. We will see in the detail next. So what we are going to see is the classification of these compounds, then the IUPAC name, writing scheme, numbering rules, and the examples. So in classification, these compounds, now for bicyclic compounds. So bicyclic compounds, as in the name, okay, it has the two rings. It has the two rings. Then it is classified based on the ring attachment. It is classified based on the ring attachment. Then the next comes the number of carbon atoms present in it. See, bicyclic compounds are those compounds which contains two ring systems. Then under bicyclic compounds, so there are three types are there. Means Spiro compounds are there. Second one comes the fused compounds, and third one is the bridged compounds. See the difference between it. Bicyclic compounds, there are three types: Spiro, fused, and the bridged. And then next, there are the biphenyls and the cumulines. So biphenyls are the compounds in which two phenyl rings attached by the carbon-carbon bond. And the cumulines, you can see in the cumulines, in which the compounds in which two or more cumulative double bonds, okay, cumulative, that is consecutive. Cumulative double bonds are present. They are not alternate bonds. Cumulines not contain alternate bonds. It is continuous, okay, not alternate bonds. So bicyclic compounds, there are Spiro compounds, fused, and the bridged. So Spiro compounds, you see, the two rings are there, and these two rings, it's attached by a single one carbon atom. So the Spiro compounds, have a common carbon atom between the two rings. So these compounds may be hydrocarbons or they may be a derivative having the double bond or a other functional group. Now the next one comes the fused compounds. The fused compounds, you can see two carbon atoms, common bridgehead atoms. Means these two rings are attached by two common carbon atoms. Okay? Fused compounds are those compounds in which two rings are attached by two common carbon atoms. Okay? Next one is the bridged compounds. So bridge compounds also contains the two rings, but you see the two carbon atoms, there is a two carbon atoms common with a bridged carbons, bridge head carbons. So this is the difference between the Spiro compounds, fused compounds and the bridged compounds. Then there is a biphenyls. So biphenyls contains the two phenyl rings which are attached by the carbon-carbon bond. And the next one comes the cumulines. The cumulines compounds, these are the not cyclic compounds. Cumulines are not cyclic. These are the open chain which contains two or more cumulative double bonds. Now we will see the Spiro compounds. So Spiro compounds, see Spiro compounds comes under bicyclic compounds. Two rings are present. Two rings are present and these two rings are attached by a single, that is one carbon atom. Now, if we have to name these Spiro compounds, then how we will name it? Then the rules for naming the Spiro compounds. The first one, the word Spiro followed by a square bracket mentioning the number of carbon atoms in each of the rings. Means whenever you have to name these Spiro compounds, so you will start with the word Spiro. You will first write this word, okay, Spiro. Then you will write the square bracket, okay, square bracket, and then square bracket. So in that square bracket, you will mention the number of carbon atoms in each of the rings, excluding the common carbon, in the ascending order separated by a dot. Means what? We will see. See here, see the first example. That is, no, we will see the fourth one example. Okay, no substituent is there in this. So which one I will show you. See, we will see this compound. See this compound. Okay. So here this compound contains two rings. That is, first you will, if you have to name this compound, okay, then you will first write the word Spiro. Then you will what write the square bracket, and in that now you will count the number of carbons in that rings. So see for so we will count this. So 1, 2, 3 in this ring, and here in this ring other one 1, 2, 3 and 4. So this small one contains 3 carbon atoms and this one contains 4 carbon atoms. So after the word Spiro, you will write the square bracket. In that, you will write the number of carbon atoms present in that ring. But there is also a rule. Now, while writing this, now two rings are there. Then you will write. You will give preference. First, you will give preference to the ascending order. Okay. So you will give preference to the smaller ring and then the larger ring. So first you will write the word Spiro, then square bracket, then you will count the numbers of these rings. Okay. So numbers excluding the common carbon. Okay. So you will not count this carbon to which by which these two rings are attached. Okay, while counting. So you will count for this ring 1, 2, 3, and for this ring 1, 2, 3, 4. Then you will write in the square bracket, you will write the number of carbon atoms of the smaller ring first and then the larger one. The smaller ring contains 3 carbons. So you will write 3 and then there is a dot. Okay? You have to remember this. Then there is a dot and then you will write the larger ring carbon atoms. That is, here it is 4. Then bracket is complete. Now the second rule, the square bracket is then followed by the number of parent alkane corresponding to the total number of carbon atoms in the rings, including the Spiro carbon atom. So after the square bracket, there is a we will write the name of the parent alkane. Okay, parent alkane. So while writing it, we will include this Spiro carbon atom. Means we will number, if the number starts from here, okay, 1, 2, 3, then this one is the 4, 5, 6, 7 and 8. So we will we counted the number of carbon atoms in the parent alkane, which are 8. 8 means it is an octane. Now here there are the double bonds are there. So in starting like 5th and then the 7th one. So here the name comes it as octa. Octane is there actually, but octa. Then there is a hyphen. Then the first double bond starts from the 5th position. Okay, so 5th position 5, comma. Then there is a 7. Then there is a hyphen and diene because 2 double bonds are there. So its name comes as Spiro square bracket 3.4, then octa 5,7 diene. The third rule comes, the numbering starts from the atom which is directly bonded to the Spiro carbon. The numbering starts from the from the atom which is directly bonded to the Spiro. That's why here we started from here first number, because this one is the Spiro carbon. So we will start numbering from this one. And while counting the number of parent alkane, you will start from the smallest ring. Okay, so we started from here 1, 2, 3, 4, 5, 6, 7, 8. So the smaller ring is numbered first. You have to remember this. The smaller ring you have to number first. And then the numbering goes through the spirocarbon atom into the larger ring. So this is the example. Now see here, when there is an unsaturation or a functional group, the numbering is done in such a way that they receive the lowest possible number. They will receive the lowest possible number. So here, take this example. Which one? This one. Okay. So this example is there. So in that, functional groups are, no, substituents are present. Functional groups, substituents are present. So here now both the rings have the same number of carbon atoms. So first substituent are present. So we will start from the carbon which is next to the Spiro. So if we start the numbering from here 1, 2, 3, then 3, and here 1, 2, 3. Means these rings contains 3 carbon atoms. Now we see the parent alkane. So 1, 2, 3, 4, 5, 6, and 7. So there are 7 carbon atoms. So it is heptane. Parent alkane is heptane. So now if the substituents are present, then you have to first write the substituent's name first, and then you have to write the name. So here second number, there is a amino group. So you will write it as a 2 amino, that is hyphen 6 methyl Spiro. Okay. Then Spiro, then there is a square bracket, 3 carbon atoms, and here in the ring 3 carbon atoms. So 3.3, and parent alkane is heptane. There is a no double bond, so it is alkane. So heptane. Now the next example, if we see, in that there are 2 rings. So if we count the carbon atoms, this ring contains 4 carbon atoms, and this contains 1, 2, 3, 4, 5 carbon atoms. So now we will start. First, you have to start the numbering carbon atom which is next to the Spiro. You will start from here. So 1, 2, 3, 4, 5. Okay. So now 5. So we are starting here. We will numbering this carbon atom, not this one, above one. It's this one, because substituents will get the least number of numbering. So 5, 6, 7, 8, 9, and 10. So parent alkane is decay. That is 10 carbon atoms are present. So first you will write the substituent position, like 6 chloro is there. So 6 chloro, then Spiro word, then there is a square bracket, then the smallest ring. Okay, we will give preference to the smallest ring. So it comes smallest here 4 carbon atoms. So 4 dot, and then here 5 carbon atoms. So 5, and total alkane contains the 10 carbon atoms. So it is decane. Now it is here also see same. Now this ring and this ring. So here you will start from the smallest ring 1, 2, 3, 4, 5, 6, 7, 8. So here it is 1 amino, 6 methoxy, Spiro, 3, 4 octane. Now see this one carbonyl group is there. So same number of carbon atoms are present in both. So here see the how it is named like Spiro. So see if the substituents are present, so they are indicated before the prefix Spiro. You have to remember. Means these are the substituents. So we have to write the substituent before the Spiro. Before the Spiro word. And they are arranged. We have to arrange it as alphabetically with respective numbers. So see this example. In this Spiro, then it contains 4 carbon atoms, 4 carbon atoms, so 4.4. And if we count the number of alkane, the number of carbon atoms in the alkane, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So nonane is there. So first and sixth position there are the carbonyl groups. So we name it as a nona 1,6 dione. So here carboxylic acid, two groups are functional groups are there, carboxylic acids. Okay. So Spiro 2, the smaller one comes first, and then the larger ring. So smaller one contains 1 and 2, 2 carbon atoms. For the see, when you write the number of carbon atoms in the bracket, you will not count this Spiro carbon atom. Okay, remember this. You will count this 1, 2 in the smaller ring first, and then you will count the number of carbon atoms in the larger one that contains 4, and it is separated by dot 2.4. Then you will count the number of parent alkane. So you will start from here. Start from here. That is 1, 2, 3. Okay. While counting the number of atoms, carbon atoms in the alkane, you will count this Spiro carbon atom also. You will number it from this here 1, 2, 3, 4, 5, 6, and 7. So you will write the name it as Spiro word first, then square bracket, then the number of carbon atoms in the ring. So the smaller one comes first, then the larger one comes. Okay. Then the total number of carbon atoms in the alkanes are 7. So it is heptane. So name it as heptane. Then first and the fifth position functional group, that is carboxylic acid. So hyphen 1, comma 5 hyphen dicarboxylic acid. Also these two compounds there is a unsaturation. So you will name it as a Spiro. Smaller one contains 4 carbon atoms, larger one contains 5 carbon atoms. So you will name it as a Spiro 4.5 deca 1,6 diene. And the next one also the Spiro 4.4 known to in. Now, after Spiro compounds, there are the fused and the bridged ring systems. So, see the difference between these two.